I want to start by welcoming everybody to today's call. This is the third call in the series, and we've chosen a time today that's more suitable for community members in Asia. I'm going to record the session and post the video on YouTube, so it'll be accessible for anybody who wasn't able to attend. I think it's fair to warn people in advance that the session is going to be recorded in case you say anything that you don't want to be publicly available afterwards. If anybody has suggestions for topics for future calls, please let me know. The aim of the sessions is to promote discussion amongst the community rather than to focus on presentation. So if you do have questions, feel free to ask them at any time. And finally, could anybody who's not speaking please mute their phone? This will help to minimize background noise and make the meeting more effective. Today we're going to continue to focus on some of the 2.0 candidate features for a release in March of next year. In particular, Tetsuya is going to talk about his work on PCI hot plug, and Changchun is going to talk about the single VirtIO driver. In addition to that, Marvin is going to talk about the DPDK test suite, which we're just in the process of releasing on dpdk.org. I know Tetsuya is having a couple of audio problems at the moment, so we'll start with Changchun on VirtIO.
Yes. Okay. So today, let's talk about the single VirtIO for the DPDK 2.0 feature, one of the 2.0 feature. And the topic will be why we need a single VirtIO implementation, and then we will talk about the status of current status, and then we will go to some items to integrate into the single VirtIO implementation. So the first topic, the first one is why we need a single VirtIO. Currently, we have 3 VirtIO PMD driver implementations. The first one is developed by Intel. It is labeled anti PMD VirtIO. We can call it VirtIO A. And the second one is the VirtIO Net PMD, which is developed by 6Win. We call it VirtIO B, just for convenience to call it later. Any questions? No. And the third one is the VirtIO by Blockade and Vayata. We can name it as VirtIO C. So we have 3 VirtIO PMD driver currently. The reason for why we need a single VirtIO is quite simple, I think. It could reduce the maintaining cost and the time for the maintainer and the developer. As we know, when we have some code changes for bug fixing or new features, if we have 3 VirtIO PMD driver, we need to port back and forth among these 3 VirtIO variant. And if we have only one single VirtIO, we don't need that effort. And another reason is that the user could reduce time on trying their applications with these 3 variants. If we have only one single VirtIO, they need to try their applications with only one variant. And about the status of the single VirtIO implementation, I have compared the VirtIO A and the VirtIO B and found that VirtIO A has covered all features of VirtIO B. As we know, both are open source on the dpdk.org. And currently, they just have similar feature set and have similar behaviors on the functionality. So I think we don't need the extra effort if we merge the volatile B into volatile A. And my understanding is the volatile A has a better modularity than volatile B because the volatile B has only one file. All the source code, or all codes and all functionality features are all in one single source file. But the volatile A has a few files which include the RX and the TX components, device, ETH device components, and PCI related codes in another source file. So I think it has better modularity. And there are some difference between the volatile A and the volatile C. Currently, I have two original patch set from Steven, so I can merge the volatile C into the volatile A. But we have not the complete source code of the volatile C. We only have the patch set. So we could merge volatile C to volatile A, but we could not do it in reverse way because we don't have the source code of the volatile C. And currently the RFC is almost ready. Because we have two original patch set. For the first original patch set, I have made them into my RFC patch set. But for the second original patch set from Steven, the merging work are in progress. So these are some items to integrate for the single volatile. We will introduce 4 new features. The first one is the software VLAN encapsulating and decapsulating. Currently, we haven't this functionality, but the blockade Voyata variant has that functionality, so we need to merge this functionality. When hardware doesn't support the VLAN strip or VLAN insertion functionality, or this functionality is not enabled in hardware side, we could provide the software VLAN stripping or VLAN insertion functionality. The second new feature is that link state interrupter. Currently, we don't have this functionality too. And the third one is MAC filter. The last one is VLAN filter. All these new features comes from the volatile C, which developed by the blockade Voyata.
Excuse me.
And another one is
Junction. Excuse me to interrupt you. You are, I think, missing one feature that SixWin did is that, and that was the main reason why we did that way. The VirtIO we are using doesn't require UIO. It doesn't require VFIO. Of course, so I think it's important to come up with a merge or a design that keep running without UIO. We need to be able to run in any guest without UIO. So that's why we have been introducing the IOPLs in the net PMDs. So I think it's an important logic because for some security reasons, some Linux vendors will not accept the UIO. Some people that want to deploy it doesn't want to use UIO because of security issues. So this IOPL has to be used because of security, and I don't see it on your slide.
Okay, so you mean currently I have missed one feature from the 6-wing variant line.
Yes, which is the security. Our solution doesn't require UIO. If you want, we can continue on the menu list, but please, you need to highlight that UIO has to be removed.
Okay, I will take off that one. So any
Thank
other thing? Okay. Okay, for the performance enhancement, we could use the weaker barrier to replace the current hard base barrier. This may improve the performance a little bit, but we don't expect obvious performance improvement for this one, but we can have a try. Besides those one, we also have some others code cleanup. And here I list most of the code cleanup or restructure. Those also come from what I will say. The first one is functionality, extract a separate function to set up the PCI resources. Currently, this functionality is written in the big function, and that's not good. I think using a separate function to do it is a better solution. The second one is remove the unnecessary adapter structure. Because that structure has only one element, so we don't need a structure to do it. We only use that element directly. The third one is remove redundant vehicle alignment, because in volatile specification, the vehicle alignment is always 4K, so we don't need a variable to hold that constant. We just need to use the constant value directly into where we need to use. And the last one is the status handling to match the Linux kernel, and it will affect the device start, stop, and close. With this change, we could restart a volatile device after volatile device stop. Yeah, and maybe there are some tiny code changes. So I will work on that one by one, and I think that's the most items to integrate in the single one volatile implementation. So I think that's all for the slices. Okay. Any question on the single volatile implementation?
Trying to continue over the main case for 6-wing.
So what this will be your so-called development machine, is it? Right. So they assign you this to you. There will be this one. Yeah.
Hello, Changchun. This is Xijong.
Hello. Hi, Xijong.
Yeah. So moving forward, there will only be a single word IO implementation, and I know the reason. Looking at history, definitely customer will come out with their own implementation. for instance, their own word I/O that they need their own report. So which means that in the future they will have to update the feature into our single word I/O implementation instead of creating a new one. Is that correct?
You can just download from.
Yes, actually you're right. Most customers has their own hotel implementation. And I think this task is not just for the 2.0. If in the future they have other features, we could continue to update their features into our single word I/O. I think you're right. Yeah.
Okay. Any other questions for Changchun? Okay. Thank you.
Can you see my slide?
Yes, you can see the slides.
Okay, I will start. So I will talk about the current status of hot plugin. So could you please see my slide? At first, I'm not so good at speaking English, so please let me know when you cannot understand my English. Yeah. So I sent a patch series to DPDK mailing list. This patch set allows DPDK application to attach or detach a physical or virtual device port while running application. So my implementation is very straightforward. When attach or detach function is called, all the data structure for managing port should be updated. So this patch set actually does not take care of PCI hot plugin. So actually, this is PCI hot plugin is done by kernel. So please see next page. This is the current status of my implementation. We need to modify three parts. One is DPDK application. Now I'm working with test PMD. Also, we need to change EAL framework. Also, now I'm working. Also, all PMD should be fixed to use a port hot plugin. Now I'm working with PCAP PMD. I guess it's almost finished, but still working. So, but I have not started other PMDs. So especially, I guess physical PMD. This should be done, but I don't have enough time to do so. So this is one of issue. So so far I've got some comments from Intel guys. So now I'm preparing V2 patch set, but design and behavior would not be mostly unchanged. This list is my patch list. Not so interesting. So if you want to hear more, I will explain appendix part. What do I do?
Yes, I think that would be very good if you could.
Okay. So basic concept of port hot plugin is DPDK application should manage port. Because DPDK application only knows which ports are attached or detached at the moment, so DPDK application should manage it. Also, my patch set will prepare interfaces like when DPDK application try to attach a port number will be returned, and DPDK application want to detach port DPDK application using a port number for detaching. So for such an interface allows DPDK application to manage ports. So actually, PCI hot plugging is done by kernel. So first, user inserts a NIC to a motherboard or something like this. So kernel recognizes the NIC, and the user can bind the NIC device to IGB UIO using a DPDK NIC file. After this, actually, the application can attach the new port. Before detaching a port must be stopped and closed. DPDK application must call RT etherdev stop and RT etherdev close before detaching port. This function we call finalization calls of PMD. But so far, all PMD doesn't have such a finalization code. So this is because we need to fix all PMD. And after fixing, we can specify new flag like RT PCE drive detachable. This is a new flag indicating a PMD supports detaching. Without this flag, you cannot detach. So this framework doesn't change EAL behavior if DPDK application doesn't call detaching or attaching. So all legacy DPDK applications still working. There are two limitations. This function are not thread safe. So DPDK application must handle it. Also, so far, this framework only supports UIO. So Linux and UIO, sorry. So BSD and PCI UIO GENIC and VFIO are not supported. So last part is maybe a little bit. Do you want to hear last part? Let's see how it works. But it's a little bit, yeah.
Yeah, I think it would be good to hear the last part.
Okay. So, yeah, this is actually terminal log, and you can see how it works. So usually, so before start talking, I want to talk about null PMD a little bit. So null PMD is a patch set I already submitted, but still no one review it, so doesn't merged. But it's very useful for testing and yeah, developing. So I just want to show how it's useful. So if we use a null PMD, please see terminal 1 log. So first, there is no port. Show port info all returns 0 port. But after port attach V is a null, actually we got 1 port. V means a virtual. If you want to add the physical port, please specify P. After attaching, type show port info all. Actually, we got 1 port. Next page. If you want to add the physical port, please bind physical NIC to IGB UIO first. So open the terminal 2 and let's see current status of NIC. Now one NIC is under kernel driver. So let's bind this NIC to IGB UIO. So actually, after binding, we can have one nick. So open terminal 1 again, and port attach P and the PCI address. Actually, we got one more port. So total port is 2. Show port info all returns the 2 port. One port is I just snip. So after attaching,
excuse me, Tetsuya, Thomas speaking. I come back to the binding to IGB UIO. Yes, just before. Don't you think it would be really more convenient to handle the binding and unbinding directly in the EAL layer instead of using a script?
Yeah, I think so. I just reuse DPDK Python script, but yeah, actually, I think so. But we don't have such a code now, so far.
I think it would be really a good improvement for the 2.0 release.
So, sorry?
I just say it would be a really good improvement for the 2.0 release to have EAL improved to handle the binding and unbinding.
Okay, I see. Yeah, let's update more after merging first. Okay, and after binding, start all ports and actually start forwarding, typing a start. And after typing stop, we got some statics. We can see actually some packet is forwarding. So if you want to detach port, first port stop all and port close all. Then type port detach P1 means P means physical. And if you want to detach virtual port, please specify V. And 1 is a port identifier. Actually, port 1 is a physical port, so port detach P1. And after detaching port V0, type show port info all. Actually, there is no port. So this is a little bit more complex example. We attach 4 virtual ports and stop and close and detach port 0 and 2. After this, start forwarding. Actually, we can do like these things. Yeah, that's all. Do you have any questions?
When you do the port attach and port detach, you have to say that it's a port V or a port P is virtual or physical. I think it would be nice to just give the name of the port, but never say if it's virtual or physical. I guess you can find the software can find if it's a virtual or physical port. You don't have to give it on the command line.
Sorry, so you mean you don't want to specify V or P?
Yes.
Okay, so this is because actually attaching a physical port or attaching a virtual port is a little bit different in because interfaces are totally different. So actually, when attaching a physical port, structure, for example, structure A is updated, but attaching virtual port, structure B is updated. So we need to separate interface for attaching a virtual port and physical port. This is because we can specify, we need to specify V or P.
Right, but from the nature of the parameter passed to port attach, you could work out if it's physical or virtual, could you? How do you attach a physical port? I mean, is it passed by PCI identifier, bus device function, to attach a physical port? Because if so, we could then look and see if it's a bus device function passed in which case we know it's physical port. Otherwise, if it starts with Ether, it must be a virtual port if it's not a PCI ID. Would something like that work?
Okay, yeah, I think so, yeah. Yeah, okay. So, yeah, actually, PCI address is but device name is totally different. So, yeah, we can do like that.
It's just one idea.
Yeah, right.
Yeah, this is Bruce here, by the way. This looks really interesting, and I think it does bring up a couple of interesting potential follow-ons. I think it was Thomas already touched on one, the whole idea of binding and unbinding from NIC drivers. How that will work is something we'll probably have to work out as well, because earlier versions of DPDK used to do unbinding, and it used to unbind every port in the system by default, which caused all sorts of problems, which is why it was subsequently removed. So if we could look at something like that again, but in a more sane way, I hope. Other thing that struck me here is with this ability to add and remove ports on the fly, your port numbers are no longer sequential. So something that struck me here is whether we want to start looking down the line. This is just a rough idea. Whether we want to start looking at having our functions to work on NIC ports to start taking pointers to ETHDEV structures rather than port ID indexes, and move away from this whole idea of having a set of port numbers. Because if they're numbers and they're not in order, well, we nearly might as well just have everything take the functions directly, which might work a lot nicer for creating especially virtual ETHDEV ports. You say create eth null 0, and instead of being told this is now your port number 15, you instead get back, right, here's your ETHDEV pointer, and it means we don't need to keep this global array inside the DPDK of port numbers. It might just make things easier, but I'm not sure.
But Bruce, the benefit of the index is that it is memory mapping agnostic. It's independent of the memory mapping, and that was the root of that design. So if you use the pointers only within the context of the thread of the DPDK application, you should be able to share the same pointers. So that's why there's an index.
Sorry, so you're saying that the same index can be shared across applications?
Yes, correct.
Okay, but if we don't have an index, I mean the indexes come and go at this point. So if you have a port, you hot plug it, and then you plug it back in again, it could very well come up with a different index. So
fine. It's fine. We wanted to come back with a new index. It's fine. It's exactly like in a kernel system. When a port leave and come back, every time you get a new interface index.
Yeah. But why not instead have it that you can query a port by PCI ID, or get a list of ports and start handling things by the virtual devices by name and the PCI ports by port ID?
Because some systems are not PCI based.
Okay, but they can still be given a unique name, can they not?
Not really. It's more in index that they have. So
I just
really
find
the
sometimes
the
that the
purpose of
index
the mapping was really to map what you have in the operating system as an interface index. So keep it as a monotonic increase. Every time the interface leaves, come back, it's a new index. And it's a global index which can be shared across any applications, and which means something.
Okay, I'm still not saying why you could actually keep that and still have all the functions work off an Ethernet pointer. Because it's very easy to convert an index to a pointer whenever you're doing a global array lookup. It's things like we could have the array for physical devices and then virtual devices work with pointers. But look, maybe it just doesn't work. It just seems strange to me to use a global array with indexes into it instead of passing around pointers directly. Since all we do in all of our ethdef functions, the first thing we do is convert it to a pointer to an ethdef structure to get at the actual data.
Yeah, that's a common practice from Stack. That's why. Okay, maybe we could continue about that on the list, Bruce, because definitely down the road, I think the rationale should be index or a pointer should be if we need it during the data path of a packet, what should be the most efficient to state CPU cycles. So if we find out that there's a way to make it more efficient, that should drive the conclusion, I think.
Okay.
One more question for you, Tetsuya, or maybe anyone else is, what about if you attach and detach a port? What about attaching and detaching a queue on a port? Adding and removing the queues for RX and TX should be fine, but mainly for RX. But sometimes you would like to, if we look at bifurcated drivers, in case of bifurcated drivers, it's very likely that we'll be attaching more and more queues during the runtime of the system. So how to handle it?
So this is Danny. I think theoretically you can do it because I tried in using the kernel driver. You can uninitialize a ISQ to compare and reinitialize it. But there are some issues there. If you want to reinitialize a queue, probably you need to restart the NIC. Restart that ports. I mean, at least you need to call a reset function. And sometimes it needs to hangs. So I'm not sure the root cause, but according to my experience, it can be done. But nobody at the moment committed to do that in DPDK.
In fact, if you look at the design of bifurcated drivers, the queue will be added, can be added almost at runtime. So it's something we will have to be careful with the arrival of.
Okay, thanks Tetsuya. That was really good, and actually your English was perfect. So the last thing we might touch on today, Waterman I know has a couple of slides on the DPDK test suite. So Waterman, we have about 15 minutes left. If you could give a kind of a high-level overview of the test suite and what we're trying to do there.
Control fully attach, detach a queue, you may run into the same issue I mentioned. If that queue is not being used before, it's okay, but it is already be used by another DPDK thread. You want that thread to detach it, and another DPDK thread to retach it. Probably you will run into the issue I mentioned.
I think it's up to the user to do it carefully. So
yes.
The user should detach and then should attach. I don't think we should have something which is thread safe.
Yes, yes. That's what I mean. You can do it, but there are some issues there. Maybe in source code, maybe in NIC itself. At the moment, I don't know. Yeah. But my point is, it does allow you to dynamically attach detach a queue instead of a port.
Okay, so maybe what we'll touch on now for the last few minutes is just the DPDK test suite. So Waterman, I know you have a couple of slides on that.
Sorry, Tim, I think Marvin will present the
Okay.
slide for
That's perfect.
DPDK.
Yep.
So can you
send
the present to me here?
There we go.
Yeah. Can you see my screen now?
Yes.
Yeah. Yes, you can see now. Yeah. Yeah. For there's not much time left, I will briefly talk about what is DPDK test suite and what's the benefit. Briefly, DPDK test suite is one Python library and can do the automation validation work for DPDK software. It will control remote tester machine and remote packet and communication and manage this board. DTS support just two types of chapter generator. Wind River DPDK-based packaging and hardware packaging like ISA. Okay. To next page, we will show the software architecture of DPDK test suite. DPDK test suite is based on Linux driver and Linux kernel, and it will use Python library, Wind River packaging, Tico shell script, and some basic Linux command like SCP and GCC and other commands, etc. And DTS will help to improve the quality of DPDK, for it will validate some basic functions like TMD, LC forward, basic functions for every commit. We almost now we have about 20 test cases ready for release. For these 20 test cases, we have verified in many and many environments, and this test case was stable and can help us to validate the DPDK source code. You can see we have several components in DPDK test suite framework, and we cannot describe them in detail today. We can just look at it. There are about 10 or even more modules in DPDK test suite. And to next page. This is the function list of DPDK test suite. It can automation configure Dude, and we can control Dude run on Fedora, Ubuntu, Wind River, FreeBSD, Red Hat, and SUSE OS. The 6 OS we have already been validated, and DTS supports this OS now. And DPDK support software and hardware traffic generators like SCAPI, DPDK-based packaging, and ISA traffic generator. Even more new traffic generator, if they can support Tico, we can support it in DPDK test suite. Okay, we can also provide the capability to manually configuration for customer use their own config and run own test case in their own environment. All the results can be output to one Excel file or text file or HTML file. Okay, let's go to next page. This is the network topology. DTS can discover network connection automatically, and we can skip this now. Okay, let's go to the benefit for DPDK.org. When developer developer submit one patch to DPDK.org, it okay. Okay, sorry. When developer submit one patch to DPDK.org, it can use DPDK test suite to verify the basic function works and verify it can be built on several packets like i686 or FreeBSD or ICC, others. We can use the DPDK test suite to verify it can the new feature can run on several OS and several configurations, and it will not have bad effect on basic functions. When we go to release process, we can use DPDK test suite to do release cycle validation on several OS, several configurations, and run performance tests, run function tests. Developer can use DTS. Developer can use DPDK test suite to create their own test suite and their own test plan. For create one new test suite in DTS, they are very simple. They are almost 5 steps. The first one is to create a new test plan and just show how you plan to validate the new feature. And step 2 to create some one test script and based around the test case, and verify the test result is like what you want. And then when you implement the test new feature patch to DPDK.org, you can use the patch and apply it on your own code and fix the gap between the test plan and the new feature, the new code. When the gap has been fixed, you can send out the test plan and the test suite in now the DPDK test suite mail list, and we can implement it into our repo code. And now. Okay. Yeah, the page. Okay, I show the latest page. Okay, this page shows the output of DPDK test suite. You can see the result, the statics, like pass 2 test cases and non-failed, and the pass rate is 100%. You can also see the detailed test results based information in one Excel file. I just copied it out, and you can see below. And there's 2 test cases and all passed. Okay. Next section we will show how the integration process of DPDK test suite. Now DPDK.org has created one new repo for DPDK test suite and add some links on the main page. Okay. This page was for DPDK getting started guide documentation. It was Python Phoenix based, and you can just make it in the repo document DTS DSC folder, and it will create several HTML files. If you open it, it will show the getting started guide as the picture. Okay. So the DTS is currently the DTS is the test tool used by Intel, but I think for Intel we can share with the open source community. So in the future we don't only publish the test framework, we also try to share the test script and test case with the community. So the member in the open source community can use our test suite
to verify their patch and the software. They also, if they have some new feature and they also want to develop some test suite, new test suite, it's also for DTS, it's easy to support them. So that tool is very open and flexible. Yeah. Okay. Sorry. Go ahead.
Okay. The last page is the mail list for DPDK DTS, and it has been created on this page mail list, and you can register yourself on it, and we can now discuss the stuff of DPDK suite from this mail list. Yeah.
In the future for Intel, we try to share our internal test report with this mail list. So maybe in the future you can see you can see a lot of the detail of test report with this mail list. So yeah, so that's all.
Yes, that's all.
So any questions? Okay. Great.
Okay, thanks Marvin, thanks Waterman. Any questions for Marvin or Waterman on the test suite?
Yeah.
Okay, so it looks like we're just about yeah. We had to rush the test suite description a little bit, but there's more information in the Getting Started guide, like Marvin said. So I think we're just about out of time for today. So thanks everybody for attending, and I'll post the recording on YouTube and send the link out. Okay, thanks everybody.